Several weeks into 2024, and we so appreciate all of you joining us for the Tech Ed Podcast. We are off to a great start with great guests, fascinating topics, and you can expect that all year long. So welcome to this episode of the Tech Ed Podcast. Thank you for joining us. We love it when you join us. We also love it when you like or comment or share our posts on social media. Everyone who tells their networks about this podcast, that is so valuable as we continue to expand our influence in securing the American dream for the next generation of STEM and workforce talent. So listen, follow, tell your friends, but another huge way that you can impact our reach is by leaving us a review right there on Apple or Spotify. Subscribe first, of course. And if you're an iPhone user and you're listening on Apple Podcasts, you just scroll down to the bottom of our show page where you will see ratings and reviews. Leave us a 5-star review if you love the show. And better yet, write a review with some comments about what you love about the Tech Ed Podcast. With that, we are going to dive into this week's guest. Thank you so much for joining us. Welcome into the Tech Ed Podcast. I am your host, Matt Kirkner. You know, we use this word game-changing quite frequently in the world of technology and innovation. Well, today we are going to talk about technology that, in my humble opinion, is absolutely game-changing for the world of manufacturing. By way of getting into that topic, last February, so February of 2022, I had the opportunity to attend the FANUC Integrator Conference. They call it the ASI Conference in San Diego, California. There are 3 things that I remember most specifically about that conference. The first one is that when you're from the Midwest like I am and you head to California in the middle of February, what do you expect? Obviously, you're going for warm weather. I actually remember one morning getting up in San Diego, California, and it was colder in San Diego than it was in my hometown of Milwaukee, Wisconsin. So the first thing I remember is that it was a really chilly week in San Diego. In spite of that chilly week, I got an incredibly warm welcome when I stood up at that conference before 400 attendees and talked about FANUC's relationship with education and how we're preparing the next generation of talent for robotics and automation. The third thing that I remember most specifically and probably most prominently is our guests' technology. As our audience knows, I spent over 20 years in manufacturing. A good portion of that period of time was running contract manufacturing operations, low volume, high mix relationships with all kinds of OEMs, where we might have 16,000 different SKUs that run through one of those operations over the course of a year. This individual's technology absolutely allows us, I believe, to automate processes that we would have never been able to automate before. It's using a combination of FANUC robotics and automation and artificial intelligence, 2 of my favorite topics. And so it's my pleasure to welcome to the Tech Ed Podcast today someone who's become a pretty good friend of mine. His name is Ariyan Kabir. Ariyan is the CEO of GrayMatter Robotics. Ariyan, it's so much fun to have you with us on the Tech Ed Podcast.
Thank you very much, Matt, for having me. I'm glad to be here and excited to talk about AI and robots.
2 of my favorite subjects, and we're going to get into that right now. I want you to start out your company, GrayMatter Robotics. What a cool name, first of all. I mean, absolutely awesome name for a company. Tell our audience a little bit about what GrayMatter Robotics is all about.
Absolutely. So at GrayMatter Robotics, at the core, we make AI software for robots. We create physics-informed AI technologies, our proprietary AI technologies, and we combine that with industrial robots, industrial sensors, and tools, and create a vertically integrated solution, a turnkey solution that we offer to manufacturers. As you mentioned, manufacturers who have high mix, high variability production. And to be more specific, in the near future, our focus is in surface finishing and surface treatment applications. These are different tool-in-hand, value-added process applications such as sanding, polishing, buffing, coating, grinding. And the reality is that, as of today in the US and also all over the world, the manufacturers are facing a tremendous shortage of skilled labor for such applications and such jobs. They have 60 to 75% labor churn in many cases. The baby boomers are retiring, the Gen X will start retiring soon. The hard reality is that the younger generation, when they try out these jobs for 2 weeks or 2 months, they decide that they want a better quality of life and they want to do something different. As a result, the manufacturers are having tremendous shortage of capacity. We have customers who have 3-year, 2-year, 4-year backlogs. We have customers who have 3 to 7 times more demand compared to the capacity. So what we're doing at GrayMatter is we are providing our all these manufacturers with smart robotic cells with essentially a digital worker that can work on this high mix, high variability, tedious and ergonomically challenging tasks that are difficult on human body. And essentially these robots are becoming smart assistants to the factory worker and helping the manufacturers to bridge the gap between their capacity and demand, and also helping them to produce the best quality. These are autonomous robots working side by side, essentially as a sidekick to the human operators on the shop floor.
It's absolutely fascinating to me. First of all, did you just use the word digital worker?
I did.
That is I mean, that's a new term for me. I absolutely love that. Tell our audience what you mean by digital worker.
Traditionally, the way automation works, Matt, is that you have to work with a system integrator. First, you spend a lot of money. You're spending essentially 90% of your CapEx budget before the solution even comes to your shop and starts producing value. We wanted to take a different approach. We wanted to go in the route of service operation. Essentially, what we do, we offer our robotic solutions to our customers, to these manufacturers in the format of a service. Our customers, all these manufacturers, they sign up for multi-year contract. Essentially, they're hiring a robot, they're hiring a digital worker, just like hiring a person. And they're paying on a monthly basis, a flat monthly fee or a flat annual fee, and there's no upfront cost associated with this operation. They're not paying anything, not even a single dollar, until the solution and the robots are really working and producing value on the shop floor. We created this model, we adopted this model to make it a win-win for the manufacturers and also for us. Everyone has skin in the game and everyone is working towards a success. We are only successful if and only when our customers are successful and are able to use our solutions to produce parts in their shop floor to the best quality.
So I really want to highlight a couple things that you're talking about here, Ariyan. The first one is, as you know, and as I mentioned in the intro, I spent an entire career in the world of manufacturing, and a good portion of that was running contract manufacturing businesses. We had companies, in one case, a spinoff of Rockwell Automation, a company I'm sure you know well, it became the largest contract metal finishing operation in the United States. We literally had 16,000 different part designs that ran through that plant every year, and every day was a different day. So, if I'm in an automotive manufacturing plant and I've spent a lot of time in those, it's a very repeatable process, right? You're building the same product, the same solution every single day, building it the same way. You create the same day every day, and it's that repeatability and standardization that really helps drive efficiency. When we're in the world of contract manufacturing, we have this situation where every day is different because you don't know what orders or what parts are going to land on your dock on a particular day, and then it's your job to figure out how you run that most efficiently. So one of the things that you're doing, and we're going to get into that in more detail, is you're solving for that. You're saying, all right, how do we automate a process like that so that we can create some repeatability, standardization, some consistency in terms of quality and so on. We'll dive into some of that, and that's game changing on its own. And then the other part of this, which is the pay for service or the subscription model. Having been around small to mid-sized manufacturing companies, you're exactly right. I mean, it is a huge risk if you're going to invest $500,000, $1 million, several $1,000,000 in some cases in automating a production line. You can be betting your entire company on the possibility that that works, and if it doesn't, now you've got this huge challenge, and you've committed all of this capital. And where your model comes in is you're saying, look, we're going to be there right alongside you. We're going to solve this problem together. You're going to pay for this service over time. We're going to make it more affordable. You don't need to go to a bank and borrow $2 million. We're going to create a subscription model. I think those two are really game-changing aspects of your technology and of your business model. Do you agree that those are the two key areas, and go into that a little more?
I would say so. I would say that, definitely the core technology where we're creating autonomous robots that can program themselves, that can address all the high mix, high variability for any new part that you present in front of the robot. So that's the core of it. And then the business model really helps all these customers, let it be a small size manufacturer or a medium size manufacturer. And even often it helps to de-risk the process for large Fortune 100 companies as well. There are many horror stories of, adopting automation, spending tens of millions of dollars, and that not working out. I would say the third key component, what makes us really unique, is our obsession with our customers and really taking the service model to the next stage. We have very high uptime across our fleet of robots in the field. Normally, if you have any problem with any of your robots or automation solution, you have to wait a few days or a few weeks before you can get it up and running for someone to come on site and fix it. We have all of our robots connected to the internet and connected to our cloud. Our robots are able to recover on their own up to an extent. It can predict, it does health monitoring and prognostics, it can predict what can go wrong, and it can take preventive measures. And sometimes our robots are sending messages to our remote support engineers in the back end. And even before something goes wrong, our remote support engineers can jump in and fix the problem. And in the worst case scenario, if something happens, again, our remote support engineers can jump in. They can also get on a call with the shop floor operator who has no knowledge of robotics or automation or engineering. And together they can get the robot up and running again in a matter of 5 minutes or 15 minutes. It's also another big push towards making robotics and automation successful in the high mix, high variability operation, that whole 24/7 support. And again, we're leveraging a lot of technology and AI to do so as well.
So I want to take just a moment, and I'm going to tell our audience what I think I saw in the several presentations from Ariyan Kabir on the technology from GrayMatter Robotics. And I won't get it perfect, and you can correct me where I miss a little bit. But the presentation that you did, by the way, last year, every year FANUC does like a contest, and it highlights the best applications by integrators, which of course are those integrating things like AI, like robotics, like programmable logic controllers and industrial controls and conveyors and so on. So it's all these integrators from all over the country. Every year, FANUC picks three, and those three that have the most interesting and game-changing technologies and solutions get to present at this ASI conference, and then they have a vote to see who wins. My vote went 100% to GrayMatter Robotics. We'll be clear about that from the get-go. But when you got up and presented this technology, Ariyan, here's what I saw. It was a surface finishing or a grinding application, and you've got a part that comes into, for instance, a contract grinding operation where every part could be every day is a little bit different. The part's different. You essentially use a robot to create a profile or a scan of the surface of that part, and then you're using an AI-backed platform to basically optimize the grinding and the surface finish of that specific part. And all of this is done automatically. All of it is done using technology, software, artificial intelligence. Then the robot will grind the part to whatever the specification or the profile is that's required, and we move on to the next part. How close was I in terms of explaining what your technology is doing?
Matt, you were spot on. You were spot on. So the way the technology works or the solution work is that it's like a microwave oven. It's as simple as that. In microwave oven, you put a food, you press a couple buttons, and you get your food ready. So we take a similar approach. Our first version of the product was made for engineers, and we soon realized that the shop floor operators are struggling. And then we really simplified it. Anyone who can run an iPhone can run our robots. You just simply bring a part in front of the robot, you press a couple buttons on the screen, and you walk away. You go back to doing something higher value add or something better to do. Then the robot will first scan the part. It has, different sensing technology built in, and the robot will scan the part to understand the 3D geometry. It creates a 3D point cloud. From that, our AI kicks in, and then it automatically determines what is the part, what are the target surface area that I have to work on, what is the fixture, what are the table, what is the environmental objects that I should not make contact with. And then the AI programs the robot itself on the fly. In pick and place operation, you have two endpoint constraints. You move objects from one place to the other. But when it comes to surface finishing and treatment, applications like sanding, grinding, or painting, you have millions of points across the whole surface. And at every point, there are dozens of constraints. You have to maintain the right position, the right contact, the right speed, the right force, the right RPM. There are many other parameters. And it becomes a computational nightmare to solve this problem in a traditional way. And that's where our, physics-informed AI technology kicks in. It programs the robot on the fly autonomously and creates a solution where the robot can move the tool and produce the right quality. At the same time, it avoids all collision, makes sure that it's not making any unwanted contact, make sure that there are flexible components in the cell, like the cables and the hoses around the robot, make sure that it doesn't entangle them or tear them. There are a lot of back-end processing that goes into the picture inside these AI algorithms. And then finally, producing the right quality is very critical. You have to use different recipe for different material. The amount of force you apply for an aluminum part, you'll be doing something different for a composite part. So we have built in this machine learned libraries for different materials so that a customer can very easily select from a drop down menu which material they want to process, and the robot can automatically produce the right quality for that desired material. And again, we are agnostic to the shape, we are agnostic to industry. You can bring a football helmet in front of our robots, or you can bring an airplane wing in front of our robots, or a bathtub. It doesn't really matter. You just press a couple buttons on the screen, the robot will scan the part, figure out the geometry, program itself, and do the job and produce the right quality.
It's absolutely incredible. I almost get goosebumps when I hear you talk about this because it totally changes the way that we can look at automating manufacturing in ways that are really, really innovative. And frankly, as someone who's spent lots of time around robotics, automation, and advanced manufacturing technology, it's something I haven't seen anywhere else. And I've got to believe your customers, first of all, haven't seen the technology anywhere else. And secondly, probably haven't seen these kind of efficiency improvements that result anywhere else. Talk a little bit about some of the benefits that your customers are deriving, not just from the workforce side, but in terms of economics and throughput and so on.
Absolutely. So, all these manufacturers, especially after COVID, everyone has been bought into the idea that we need automation. We need automation to bridge the gap between demand and capacity. We need automation to get the right quality, especially with this declining workforce. Now, the benefits that all these manufacturers see when they adopt our solution are multifold. Number one, if you were previously trying to run a 10 people operation, but you could hire only two people, now you can add two robots. Now you can run a two people and two robot operation to produce the same output as a 10-person operation. Typically, we see 2 to 4 times more throughput from our robots as compared to manual operation. The second big benefit that our customers see is a consistent quality. Every single time you have consistent quality. For a range of input conditions, the robots always produce a consistent output. That helps you to eliminate a lot of cost associated with QC, repair, rework, or scrap. So it eliminates the need for repair, rework, and scrap. The third thing, when we started the company, this third benefit, we really did not comprehend that we're going to see this benefit when we started the company. So the third big benefit we're seeing is a massive contribution towards sustainability. What we are learning is that we are helping our customers to save a lot of consumables. Let it be sandpaper, let it be paint material, you name it. Across the board, our robots are able to save 30 to 70% of the consumables as compared to manual operation. It's because, if you're a human operator, you get tired and you want to rapidly switch out your consumables such as sandpaper so that you get the most efficiency out of your body, right? However, for a robot, the robot doesn't get tired. And as the life of the sandpaper is changing, again, we use a different AI technology to track the health of the tools and consumables. And we can leverage the robot's ability to keep on adjusting the recipe, the force, the speed, the different parameters and variables to get the full life out of those consumables. And that enables us to save 30 to 70% of consumables for a football helmet maker or an aircraft manufacturers. And when you do this across the board, across all these manufacturers, that's a massive contribution towards environmental sustainability.
All the turnaround work that I did in manufacturing, you always focused on three things. Number one was throughput. Number two was yield or consistency or quality, and number three was material consumption. And if you could solve for all three of those, you could run a really, really efficient manufacturing operation. And in fact, a lot of times people would say, what's the magic to turning these companies around? And a lot of times it's not really magic. It's really just going in to the fundamentals of manufacturing and understanding that if I can produce more good parts using less materials and less resources, the model works pretty well.
Right.
And really, you've focused on all three of those. The first two, 2 to 4 time increase in throughput. And for our audience that may not be familiar with that term, what we're talking about is how many parts per period of time. So in other words, how many parts per hour can I produce? Then we get into yield or consistency. How many of those parts are good? We always want to shoot for obviously the highest consistency and the highest yield so that every part that comes off the line can be used in whatever comes in the next operation. And then finally, reducing component costs or reducing material costs. In my time in surface finishing, it was always paint, powder, water, chemistry, cleaning materials, all of these different variables that go into running a really efficient manufacturing operation. And you've really found, I guess the third one was a little bit by accident, but finding, I love the way you tie that to sustainability. But I look at that as not just sustainability, but also manufacturing costs, and that just drives right to the gross profit and right to the EBITDA line. That's just free money if you can figure that solution out. So awesome that way. We kind of a little bit maybe brushed over the fact that you're like shrugging your shoulders and saying, "Oh yeah, we use an AI platform, and so we use this artificial intelligence to figure out how to do this." I want to explore that a little bit more. Everybody's about artificial intelligence. We've got all these different applications. Obviously, we're into the Chat GPT-4 and Anthropic and all these other fascinating technologies that were being used in office operations and manufacturing operations. Without giving up anything that's proprietary, I'd love to understand, Ariyan, a little bit more about how you're using artificial intelligence. What's the platform, if you can share that? What's going on in the background here that's enabling you to do all this?
AI is very broad, Matt, and there are many different use cases of AI. Now, what we do, it's a full stack solution, and there are many different modules that go inside the robot brain, I would say. There are modules of perception. How do you understand the world? How do you understand the part? There are modules of the robot programming itself, generating its own trajectory, and how it can move the tool efficiently and safely. There are modules around how can the robot learn the behavior of a new material? How can the robot learn from a very skilled operator? What's the best strategy to take when we are, approaching a certain kinds of parts or material? There are technologies around how do we estimate, how do we monitor the health, how do we run advanced prognostics and health diagnosis. So we use different kinds of AI, proprietary AI technology in each of those verticals. And there are many other verticals, but at a high level, those are the four major verticals. And we have different proprietary technologies in each of them. What I would like to highlight is one of them, which is our physics-informed AI technology. In a traditional AI, when you have pure data-driven approach, let's say you're training a model to detect whether it's a cat or a dog, or you're training, a large language model to, be able to communicate with humans in a as close as a human language, right? Or be able to extract information and make, provide it to you in a presentable way. However, those are all great, and it's okay if you make a mistake in those scenarios. If Netflix gives you a bad suggestion for a movie, there's no harm, no foul. However, when it comes to the kind of work we're doing, when the robot is interacting with a physical part, these are cyber physical systems. Or even if you think about self-driving cars, right? The stakes are really high. You can't really afford to make a mistake. What we're doing is that we're combining data-driven approach with physics, and we're creating these physics-informed AI technologies where we are not letting the robot to just follow a machine learned model to take actions, capturing the understanding from the realm of physics to understand the boundary conditions and creating a safe behavior for the robot to ensure the safety for the parts, to ensure the safety for the robots, and also to ensure the safety for human who are operating with the robot in the robotic cell. So that's a big push towards safety. And again, being able to do so in a real-time fashion, in a very short compute time, is the real innovation.
Are you developing all of this from scratch? Are you leveraging other technology or other platforms that are out there? Are you integrating maybe on the back end different solutions? How, where does that start?
The core AI technologies that we leverage, those are all our proprietary technologies. Those are the items that we develop from scratch, and we have certain patents around certain technologies as well. What we do not develop is the technology that has been already become very mature. For example, let's say the robots. We're not making robot. We are working with our partners who makes the best robots in the world, who are the market leaders in industrial robots, and we leverage their robot. We leverage their communication platform for the robots, and essentially our core technology and the AI, it sits in a black box and it communicates to the robot, to the sensor, to the tool, which are made by our partners in real time at a very high frequency, and controls them as peripherals, basically.
So who does this work? I mean, is this, I guess two questions. I mean, are these roboticists? Are they data scientists? Are they programmers? And then a little bit about your background and how you ended up in a job like this.
Sure, it's all of the above. So in our team, we have a very wide range of professionals, anyone from computer scientists to electrical engineers to mechanical engineers, roboticists, AI scientists, all the way down to the engineers who are expert in automation and PLC and power electronics and whatnot. Robotics, when it comes to marrying AI with robotics, providing an autonomous solution to the end customers, we really have to take a vertical integration approach. And that pushes us to have all these talents, all these experts from this wide range of domain come together and create a turnkey solution that works for our customers. And our customers are not left hanging. How do I combine these two puzzle pieces? We are giving them a full turnkey solution, and that really pushes us to create this diverse team of talent of different engineering and science discipline. And also at the same time, again, Matt, you recognize this. What we're doing is not just about moving robots and making autonomous robots. End of the day, we have to produce the right quality. So there's a lot of material science that goes into the play. How do you convert a traditional artisan approach into a science-based approach? So we have our tech fellows who come from strong manufacturing background, who helps us to convert some of these traditional artisan approach and really extracts the material science and the process physics out of it and helps us to bleed it into our AI technologies.
And Ariyan Kabir's background, how did you find your way to this?
I have been fortunate to be part of a PhD program at USC. So that's where, I met my co-founders, Bruel and SK. And, USC has a strong industry affiliated program. So Bruel and I, we were, doing our PhD at the intersection of robotics and artificial intelligence. We had been playing around with many different applications as and when different projects come into the lab. However, USC has a very strong industry affiliated program as part of their Center for Advanced Manufacturing. That really gave us the opportunity to interact very closely with a wide range of manufacturers. Let it be large Fortune 100 companies, let it be big aerospace corporations, or let it be small and medium sized businesses. Those exposures and experiences really gave us the opportunity to learn from these manufacturers directly what are the pain points they're facing, what are the different big challenges and bottlenecks they're facing. And that really pushed us into thinking how do we enable them with robots, with autonomous robots? If you look at the electronics industry and automotive industry, they have been successfully using robots for decades, right? However, over there you have machined metal parts and stamped metal parts. You can program the robot one time, and the robots can repeat the same movement again and again, blindly, repeatedly. And it works out beautifully because you're putting the parts exactly at the same spot with fixed fixtures, and all the parts are identical. However, that's only about 10% of manufacturing. And as soon as you go into the next 90% of manufacturing, which are high mix, high variability by nature, let it be a guitar or a football helmet or your household sinks, countertops, bathtubs, or buses, trains, trucks, fire trucks, ambulances, aircrafts, not just commercial aviation, defense aircrafts, the next generation rockets, eVTOLs, the entire energy sector, let it be renewable, oil and gas, or nuclear. It's all high mix, high variability in nature, anything and everything around us. Over there, you can't rely on a pre-programmed robot to be successful. You need autonomous solution. That really pushed us into thinking, how do we create technology to make robots autonomous to work in this high mix, high variability manufacturing sector? There many opportunities to play with robots to for making pizza or delivering food. However, we really wanted to focus on something really impactful. That's the need of the hour for the nation, for the world. Manufacturing drives our economy. If you stop producing parts, you can't run services with them, you cannot run ads for them, you cannot sell them. It has a cascading catastrophic effect on our whole economy. The way we think about it, we are helping people to get a better quality of life with these smart workers, but at the same time, we are helping to build the backbone of economy by helping all these manufacturers.
So PhD at USC at the intersection of robotics and artificial intelligence. Obviously, that's fascinating. What came before your PhD work? What did you do your master's and your undergrad in?
I don't have a master's degree, but I pursued my undergrad in electrical engineering.
Okay, awesome. So undergrad, and was that at USC as well?
No, I actually grew up in Bangladesh. So I did my undergrad in Bangladesh University of Engineering and Technology. Think of it as Caltech or MIT of Bangladesh. And during my undergrad, it was pretty evident that the robots today are marvelous. They can do amazing job. However, the missing link for robots was their decision making ability for them to be useful for a broader range of application. That really motivated me to pursue my PhD at the intersection of robotics and artificial intelligence. And I really wanted to, do something meaningful in my lifetime and see that impact. That really motivated us at the first opportunity when role me and SK had to really create a solution that can help the world today and that can help manufacturers and millions of people today to take that opportunity and run with it.
Doing something meaningful indeed. It's incredible the technology that you've created and the future that lays before you. You know, every time I see your technology, Ariane, and you and I met actually at the FANUC ASI conference initially. I know you're a huge fan of FANUC Robotics. You talked a little while ago about partnering with the best robotic systems and partners in the world. What was it that led you to FANUC, and why is that such a core part of your technology?
Yeah, so FANUC has been a wonderful partner. So we got to know our friends from FANUC even before we started the company. So our local friends from Southern California, Scott and David, we got to know them during our time at USC. They visited our lab. They were fascinated by some of the early version of technology or what's possible. And then when we decided to start the company, they helped us with a free robot, with a loaner robot. That hey, why don't you use a robot, why don't you play with it and see if you can really translate what your technology with our robots. That really helped us as a when we started the company, a very young startup of like two people and a couple of interns, and without any resources. Fanuc really helped us with the right resource. And then over the time we really built a solid partnership with Fanuc, working directly with their HQ, both in the US as well as in Japan. And they really helped us to open up a lot of their backend technologies for us to be able to access and enable the robots to do what we make them to do today. And it has been a very synergistic partnership. It's been a win-win for both Fanuc and GrayMatter to open up this new market. And Fanuc, as a market leader, they really strive hard to the success of customers. They have a strong, set of support people. They have a large army of foot soldiers who can really help you when you need the help when things go wrong. And that combination of striving towards innovation and really looking into what the future holds and unlocking the potential of the technology, plus the mindset to really make customers successful and having that support and services available, that really makes this partnership wonderful between GrayMatter and Fanuc.
Speaking of amazing partners, we've got partners with OEMs. We have partnerships with technology companies, with robotics companies, partnerships with education, really important as well. You talk about your educational pathway and how you were inspired into doing the work that you're doing today, Ariane. Talk to us a little bit about the world of education and your thoughts on what we need to be doing and should be thinking about as we equip students for careers like the ones at GrayMatter Robotics. And as you answer that question, I'd also like you to talk a little bit about the recent growth just in the number of people working in your organization. So you really do have some great career opportunities, continue to expand your workforce. So how is that workforce expanding? And then what do educators need to do to inspire young people toward these types of careers?
Absolutely. So we have been growing pretty fast, Matt. We have been very fortunate. At the end of 2022, we were a 25 people company. At the end of 2023, we are already a 60 people company, and we are growing really strong. So 2023 has been a year of tremendous growth for GrayMatter, both in terms of our headcount as well as number of robots out in the field, and creating broader impacts for our customers and all these manufacturers. Now, when it comes to robotics and artificial intelligence and automation, we need people from different disciplines. We need folks with different engineering background, let it be computer science, electrical engineering, mechanical engineering. We need people with background in artificial intelligence. Some folks may need to have deeper expertise with PhDs, but we also need a lot of people from the automation background with working hands-on with mechatronics, working hands-on with robots. And a lot of those things you don't really learn at school, right? And some of the initiative that you're taking at Matt, your organization is taking, is amazing to really build up that next generation workforce who can have that hands-on experience to learn from trial by fire, essentially learn by playing with these robots and understanding the practical challenges and practical opportunities and the opportunities are endless. So I would say we need strong at the core. Whenever we hire someone, we try to identify, are they a very strong problem solver? Do they have alignment, strong alignment with our mission? End of the day, it's a lot of work, it's a lot of hard work. Unless and until you have that strong mission alignment, and unless and until you have that strong problem solving aptitude in your DNA, you're probably gonna struggle. And on top of that, the education and the background, both in technical expertise as well as, in certain roles, we need the expertise of interacting with customers, really being able to extract the problems and understanding the requirements of the customers and being able to give them the comfort and communicating to the customers the technology in a way that translates and becomes understandable to them. That's a whole different skill set, and that's a whole different category of education, I would say. So again, there are many different initiatives we can take to really prepare the next generation of workforce to become really good at both in technology, in fundamental problem solving, to be practical in when it comes to problem solving, so that they're not wasting their time in solving the wrong problem, understanding the problem first, what really matters, taking a first principle approach to solving them, but also at the same time really staying close to the customers or the core problem and being able to communicate very effectively. Now, at the same time, the other thing I want to highlight, Matt, is that, I talked about GrayMatter and, what kind of workforce or skill set that we need. However, when I look at manufacturing today and the kind of workforce that all these manufacturers need, there are a lot of opportunities for skilled professions. And I believe as a nation, we really have to push more towards building that curriculum to help, trade workers and skilled workers to bridge those gaps, because not everyone with an expertise in AI can really solve all the problems, right? We need a very diverse set of next generation experts and very diverse set of skills to win overall.
It's one of the things we talk about quite frequently when we're talking about the application of data science, business analytics, artificial intelligence, and in manufacturing and business in general. Is that it's not just about the algorithms. It's not just about the data science. We're actually working on equipment. We're working on systems. We're working on processes. And if we don't understand those processes, the work that we do at the data side is probably not going to add a lot of value, and actually
Right.
can create situations where we spin our wheels. I think that's where, when you talk about the combination of understanding technology, understanding problem solving, understanding problem solving, and starting with the right issues to make sure that we're being efficient about it, taking a first principled approach to how we innovate, all of those things really, really important. And then layering on top or beneath or both, understanding of things like automation, technology, mechatronics, and so on. So I really like the way that you answered that question. You mentioned mission a couple times there, Ariyan, and the importance of having team members that are dedicated to your mission. We talked a little bit about the importance of the work you're doing earlier in the podcast, but if you could summarize that mission in a sentence or two, what does that sound like?
Matt, at the core, our objective is to, unlock the full potential of humanity. Our goal is to empower millions of people with these technologies so that they can, essentially take a leap and improve the quality of their lives, and they can focus their time and attention in something more meaningful other than working on tedious and ergonomically challenging tasks. At the same time, as I was mentioning, our focus is to really elevate manufacturing and make sure that we can secure our future economy. And as a couple of the side effects that we're observing, we are also contributing towards national security, because unless and until you have some of these manufacturing capability, you cannot really do manufacture certain products and articles that are of national interest onshore or nearshore. So that's very critical, and we're seeing that we're contributing towards that. At the same time, we're observing that we're contributing towards the environmental sustainability by helping to save a lot of consumables. And as you correctly pointed out, that also helps towards saving cost. So overall, these are the four pillars of our mission. And whenever we hire someone at GrayMatter, we want to make sure that they're aligned with one or the all of these pillars. And you really have to focus on the end goal. It's not about doing a job. It's more about delivering results and being able to do something really impactful, and something that's also very hard. That requires you to have that strong motivation coming from within, and that's where the mission alignment becomes super critical and super important. Otherwise, you'll not be able to work through or punch through the wall when you hit a roadblock. And it's a lot of work, it's a lot of hard work, it's a lot of exciting work. And unless and until you have that mission alignment, it's going to be quite impossible for someone to survive in this kind of high growth, fast paced environment where you're pushing the boundary every single day.
Percent agree. Money's fine and money's important to some degree, and certainly prestige and promotions and those kind of things important to some degree, and won't argue with any of that. But at the end of the day, in the best companies, and I like to think that I've been involved with a number of them, it's the organizations that are really doing something bigger than themselves and trying to make the world a better place, changing lives, improving sustainability, whatever that is, and focusing on how you really truly are making the world a better place. And that's really what creates stickiness with team members. When you feel a part of that mission, when you feel like you're doing important work, the money and the prestige and so on always take care of themselves. Those are the results of focusing on the mission and moving the organization forward and doing great things for great people. And that's exactly what you are doing, not just now, but into the future. And I want to focus a little bit now, Ariyan, on the future of GrayMatter Robotics. And you touched on a little bit of this already. I became familiar with your technology in the surface finishing space, and that was the application you presented at the conference we were both at last February. And you mentioned things already like the automotive industry, like the appliance industry. I mean, all these different applications. You talked about the application for energy, really anywhere where we have this high mix, high variability product line or combination of products. So as you kind of look forward, highlight maybe one or two that you think are really, really interesting of all those that you're working on. Where do you see the next step of growth for GrayMatter Robotics, and which industry spaces are most important to you?
Right. I'll probably keep it at a very high level. So, in short term, in near term, our focus is going to remain in different tool in hand value added operations, right? Wherever you take a tool in your hand, you move it over the surface, you make some value added change to the surface or value added change to the part that you're working with. That's going to be our near term focus. Being able to become the best solution provider for the space of different process applications, tool in hand value added operations. As we continue to grow, we are going to continue staying focused on different service applications and different applications that requires a lot of human labor. However, people do not necessarily enjoy doing those jobs by hand or do not enjoy having those jobs. There, wherever we see it's a must-have operation, it's a must-have service or manufacturing or other industrial jobs. And there's a declining population due to the tedious and ergonomically challenging nature of those jobs, or due to certain reasons why that job is undesirable for humans. Those are the places we're going to continue focusing on and expanding our horizon to continue helping the society.
So, and I'll just comment for our audience, if they want a little bit of better idea of the kinds of things that you're talking about in kind of a public setting. You're very active on LinkedIn, and I follow a lot of your posts on LinkedIn. And just looking at the kinds of organizations that you're engaging with, the people that are visiting your operation, really gives you a sense for the magnitude and the level of the types of partners that you're talking to. So without giving anything away, I'll invite everybody to follow Ariyan Kabir on LinkedIn and get a better idea of some of the partnerships that you're building, which are really, really impressive. Just to play off on that last conversation and some of the future applications, the thing that really fascinated me, and I've touched on this a couple of times already, Ariyan, about your technology is really thinking back to my time in advanced manufacturing, running contract metal finishing operations. And in those spaces, if you think about, in one case, I had a company that had 16 different production lines where we were doing zinc plating, silver plating, tin plating, phosphating, zinc nickel plating, and the list goes on and on, chromate conversions on zinc and aluminum, and so on. And you think about how an operation like that works. We had a big automated line, and at that time, I mean, working with some of the automation that we had was really advanced automation for technology of that era, which might have been 10 or 15 years ago. And then we've got all of these parts, literally millions of parts that would go through that plant every year. And we'd have to take those parts out of a bin, place them on some type of a conveyorized coating line, and then they would go through a process. And then on the back end, somebody would have to do the same thing. Really, really difficult, challenging operations to automate because all the parts look different. It's a different day every day. We talked about that a little bit earlier. And so we would have literally hundreds of people that would work in those organizations that were taking parts out of bins and placing them on a rack. certainly really hardworking, valuable people doing great work. But to your earlier point, not the most interesting, invigorating work on the planet, not the kind of thing that somebody would be excited to come in and do, as opposed to, say, working with automation and understanding advanced manufacturing technology today. So, as you look to the future, are those the kind of operations where you can see yourself really adding huge value? Are we on the right track there?
Yeah, no, I think you're absolutely correct. So the way we look at the future is that, being able to help all these manufacturers end to end, right? So at the moment we are helping them by providing cellular solution for certain applications. But as we continue growing, we want to expand horizontally and keep on giving all these manufacturers solution for every single stage. And then again, you can think of a future where, you have autonomous mobile robots moving parts from station to station, and that way you don't even have a single point of failure of such as a conveyor belt. And then you have different stations with different robots focused on different application, and then the AGVs are able to take the part through all the different stages, and at the end you can run a full factory probably with just one person supervising at a very high level, or if the need be they can go and troubleshoot if there's any problem that arise. But that's the future that we're looking forward to, like bringing true innovation in manufacturing, helping manufacturers to rethink and reimagine how their factories run, how they can sequence all these operations, but at the same time, giving them the opportunity and the right toolkit to innovate even in their product line. With the help of all these adaptive technologies and smart new technologies, and with the help of AI, they can truly innovate in their product. They can now imagine new types of product features that was not previously possible due to the limitations of manufacturing processes.
No, that I mean, we could go on off of that off of that conversation for probably an entire episode. I think about it and I'm envisioning as you go through that answer, Ariane, you've got, let's turn the page forward 5, 10, 15 years. You've got an autonomous vehicle like a truck that's actually delivering parts to or delivering materials to a specific manufacturing operation. That truck doesn't have a driver; it's being driven autonomously. And then you've got an autonomous mobile robot or an automated guided vehicle, as you suggest, picking parts up off of that truck and taking them into a staging area, bringing those materials on a real time basis into the manufacturing plant, having a robot using your technology that is loading and unloading equipment, loading and unloading machines, and performing work on those specific parts. That process gets done. It goes back to an AGV or an AMR and back to the next manufacturing operation until we have a completed solution for the consumer or for whatever comes next. And now you start to think about, and this was an aspect you just brought up that really hadn't occurred to me, and we hadn't spent much time working on in this particular podcast. But you think about design for manufacturability. That's a term that we use a lot of time when we're engineering new products and thinking about not just how do we want the consumer to use this product, but how are we going to make it? And how are we going to make it in a way that is repeatable, that has consistent quality, and that we can do so at a cost that's appealing to the consumer. And now, because we can have more variability in the manufacturing process, thanks to technologies like yours, we can have a lot more consumer variation in terms of creating products that are perfectly fit for specific applications. Not even something that we really spent much time on in today's podcast, but a really fascinating look at the future of technology. It sounds like you're thinking about it exactly the same way.
No, absolutely. You're 100% correct, Matt. So the way we see the future is, there are two broad category that's going to open up. One, you can manufacture very close to the consumers or the end users. And number two, you can do mass customization and mass personalization, right? So Amazon has really pushed us into this mindset of, I want this now, in 2 hours, in a day, right? But now, in the future, with the advent of all these different technologies, and as they mature, you can now get personalized product, a personalized shoe or a personalized T-shirt or a personalized car in that very short amount of time, and that is manufactured very close to you and delivered to you. You can start running all these micro factories that can run mass customization and mass personalization and deliver the product to the end user in a very short time.
What an exciting time for manufacturing. You're right. You think about game changers, and you think about people like Elon Musk, and you think about people like Jeff Bezos with Amazon, and I almost feel like, without being too too flattering to you. And we might be talking to the future Jeff Bezos of manufacturing and advanced manufacturing here on the Tech Ed podcast, given the innovation and the technology that you're bringing to the market. And as we think about the future of manufacturing and manufacturing getting closer and closer to the point of consumption, which, by the way, I believe is really, really good news for those of us in manufacturing here in the United States of America. I think the future is really, really bright. It's going to look a lot different than it did 10, 15 years ago, but in a really, really good way. So excited about the future, not just for GrayMatter Robotics, but for the entire field of advanced manufacturing. Had a lot of time and a lot of fun here dreaming about the future, Ariyan. I want to end our time together by looking in the rearview mirror, looking back into the past. And I'm going to ask you two questions. I'm going to save the final one we ask every podcast guest for last. But I want to start out because you mentioned a little bit earlier, growing up in Bangladesh. I've got to believe that's where you were when you were about 15 years old. So before we ask our final question, tell us a little bit about what life is like for a 15-year-old in Bangladesh.
I had been very fortunate, Matt, to be honest. I was one of the privileged one to have all the right set of education. My family always supported higher education, and they always supported, thinking about dreaming big and not really limiting your thought process in, okay, you can do only this. So I've been very fortunate to grow up in a family that supported higher education and that supported, thinking really out of the box. But I would say, anyone growing up, we really want to help them encourage that, help them understand and believe in the possibilities, help them understand to see the pathway, and help them to understand that all these different technologies are possible. And again, none of them have come to realization overnight. It's never an overnight success, or it's never an overnight accomplishment. It's a gradual build up, and helping to encourage the next generation to stick to that, stay focused and really focus on building up gradually, and really keeping the eye on the end goal, and then walking backwards to figure out what are the steps, what are the skill sets that I need to work on, what are the knowledge that I have to bridge that I have to bridge gaps on, and then basically really focusing on achieving their end goal and their aspirations. So it's very much possible for anyone and everyone, especially today with the access of all the knowledge and information that we have. And not just searching something on Google, but with Chat GPT and getting a very consolidated information, it's becoming so much easier as compared to before for anyone and everyone to become really good at something that they really aspire to be.
We really are at a fascinating point and intersection with the democratization of information, of education, of opportunity, and really the sky is the limit for anybody that can understand that path and understand that route. It's not necessarily doesn't happen on autopilot, and we still have a lot of work to do to create understanding and knowledge and inspiration for young people to really capture and appreciate what kinds of opportunities lie before them, and whether that's an amazing career at GrayMatter Robotics and advanced manufacturing, or in any of these other endeavors that involve technology and involve adding value and involve mission, all of which we've talked about today. As we wrap up our time together, Ariyan, and we think about all these opportunities for all these young people, I want to go back in time to your time as a 15-year-old young individual growing up in Bangladesh with your whole life in front of you, and look at all the things that you've managed to do. But if you could go back in time and give that young Ariyan Kabir one piece of advice, what would that piece of advice be?
I'd say stay focused. Don't think about a plan B.
There you go. I like it. Stay focused, figure out what you what you want to do, where you want to go, and stay on that plan. You've certainly done that. What an amazing career you've had with so much future in front of you, Ariyan, but building an incredible team at GrayMatter Robotics, technology that I don't get like blown away by too many things. That only happens a couple times a year, and your technology and the way you explained it when we were together last February, it literally blew me away. And the things that you're doing with your company and with your customers and the business model that you've selected and all the work that's gone on into this. Really, really impressive, and an impressive episode here of the Tech Ed Podcast with my friend Ariyan Kabir, the co-founder and CEO of GrayMatter Robotics. Ariyan, thank you so much for being with us.
Thank you very much, man. Thank you for having me. I had a wonderful discussion, and I really admire and appreciate all the work you are doing for the next generation and for our education.
Wow, what an incredible episode of the Tech Ed Podcast with our friend Ariyan Kabir, the co-founder and the CEO of GrayMatter Robotics. As I suggested in the intro, that is absolutely game-changing technology. I haven't seen anything like it. I'm so excited for what the future of that company holds. So if you are as fascinated by this episode as I was, and you want the show notes, and our production team does an amazing job with the show notes, sharing all of the links and all of the resources mentioned in this episode. Where do you find those? Head on over to techedpodcast.com/GrayMatter. And note that Gray is spelled Gray. So GrayMatter, GrayMatter. The best show notes in the business, and you will find so much helpful information at the URL. Now, don't forget that we are active on LinkedIn. We are all over Facebook. We are on Instagram. We are on TikTok, and we post all the time about new episodes, featured insight, and all of the amazing content that you get here on the Tech Ed Podcast. So find us on your favorite social platform and say hi. We would love to connect. We'll see you next week.